Hi everyone, here we have GATE question from 2021 from EEE department. The question is from linear algebra. Here the question, let A be a 10 by 10 order matrix such that A power 5 is a null matrix and I be an identity matrix of same order 10 by 10. Then the question is find the determinant of A plus I. So we need to find the determinant of this A plus I. So I want to proceed this by the concept of eigenvalues. That means determinant of the square matrix is exactly equivalent to product of eigenvalues, right? So that concept I want to approach. Okay, so first what is given to us? So A is of order 10 by 10 is given. Okay, what kind of entries we don't know, but A power 5 is a null matrix. This we know. A power 5 is a null matrix. Since A is of order 10 by 10, therefore A power 5 is of order 10 by 10. So that means this matrix is of order 10 by 10, but all the entries are zeros, right? So 0, 0, 0 up to so on 0. So these are 10 columns and similarly 10 rows, 10 by 10, 10 rows, 10 columns like this. So 0, 0, 0, 0 up to so on 0. So therefore 0 and so therefore 0, 0, 0 and up to so on. Okay. Right. So therefore what are the diagonal entries now? All the diagonal entries are what? Zeros. Since all the diagonal entries are zeros, look at its it's a kind of diagonal matrix, right? Then what are the eigenvalues of such diagonal matrix? Simply elements which are sitting on the principal diagonal. Therefore, what are the eigenvalues of A power 5 now? Simply all the eigenvalues are zeros, right? So therefore eigenvalues of A power 5 are 0. Okay, let's have the question. So all the eigenvalues of A power 5 are 0. We got this, right? So by using one property, look at this property. If lambda 1 to lambda n, if lambda 1 to lambda n are eigenvalues of matrix A, square matrix A of order n by n, it is of order n by n, that's why n eigenvalues are existed. Then the conclusion is lambda 1 raised k up to so on lambda n raised k are the new eigenvalues of the new matrix A power k for any positive integer k, right? That means here, so if lambda is an eigenvalue of A, then lambda power 5 is an eigenvalue of A power 5. Then lambda power 6 is an eigenvalue of A power 6 likewise. Okay. So therefore here, therefore what are the eigenvalues of A power 5? So therefore lambda power 5 are the eigenvalues of A power 5, right? A power 5. And lambdas are eigenvalues of A, right? Based on this property. So lambda power 5 is an eigenvalue of A power 5. Lambda is an eigenvalue of A. So lambda power 5 is an eigenvalue of A power 5, but here A power 5 eigenvalues are how much? What they are? They are zeros. Eigenvalues of A power 5 are zeros, but eigenvalues of A power 5 is lambda power 5. So therefore, lambda power 5 indirectly 0, isn't it? Because A power 5 eigenvalues are zeros, just now we found. So therefore, lambda power 5 is 0. So that implies what? Lambdas are zeros. Therefore, lambda is 0. But what is lambda? Lambda is an eigenvalue of A. So indirectly, eigenvalues of A also we got. So therefore, eigenvalues of A are zeros. How many eigenvalues exist for A? Because A is of order 10 by 10. So all the 10 eigenvalues are zeros. Lambda 1, lambda 2, lambda 3 up to so on lambda 10. All those are zeros. Similarly, for A power 5 also. All the eigenvalues are 0 means what? All the eigenvalues are lambda 1, lambda 2 up to so on lambda n or lambda 10. All those are zeros, right? But my question is, what is the determinant of A plus I, right? So before that, I want eigenvalues of A plus I. So what are the eigenvalues of A plus I? So eigenvalues of A plus I, simply what are the eigenvalues of A? Eigenvalues of A are just now we computed, which are zeros, plus eigenvalues of I. I is identity matrix. What are the entries which are on principal diagonal? only ones, right? So therefore eigenvalues are ones. All the eigenvalues are ones. So therefore 1. So therefore 0 plus 1 is 0. So therefore eigenvalues of A plus I, the matrix A plus I, are ones. All are ones. That is all the eigenvalues. So how many eigenvalues exist here? Because A is of order 10 by 10, I is of order 10 by 10. So sum of two 10 by 10 matrices, again 10 by 10 matrix. So 10 eigenvalues exist. So those are lambda 1 is equals to lambda 2 is equals to up to so on lambda 10. So all those eigenvalues are ones only. Okay. So finally what I want determinant of A plus I. So determinant of A plus I. So this I want actually. So determinant of A plus I is nothing but what? So by this property, the product of eigenvalues is nothing but determinant of a square matrix. So det A is nothing but product of eigenvalues. Therefore, det of one matrix is nothing but product of this matrix eigenvalues. So this entire matrix eigenvalues are lambda 1, lambda 2, up to so on lambda n, lambda 10. Therefore their product I want. So their product is nothing but so 1 into 1 into 1 into up to so on 1. So how much? 1. So therefore what is the answer? 1. So determinant of A plus I is